Alright, so we've talked about how to find the volume of spheres and cylinders and cubes, and so now we can do some applications with that. So it says a water bottle is a cylinder with a radius of 1 inch and a height of 7 inches, 7.5 inches. So we've got a radius of 1 inch and a height of 7.5 inches. What is the bottle's volume? So this bottle is essentially a circular cylinder here. So I've got a radius of 1 inch and I've got a height of 7.5 inches. So we can use our volume formula. Volume is pi r squared h. So this is going to be pi, we'll estimate that as 3.14. R, so 1 inch squared and 7.5 inches. Alright, and so now we can go ahead and distribute or multiply this 1 inch. So we've got 1 inch squared. So 3.14. 1 times 1 inches squared, right? And then 7.5 inches. So that's just going to give us 3.14 times 1, so 3.14. And then inches squared times 7.5 inches. And then remember that the units are going to multiply together, so we can kind of think about collecting like terms. So 3.14 times 7.5 inches squared times inches. So we get 3.14 times 7.5 inches cubed, which makes sense. Volumes should be inches cubed. So then we've got 3.14 times 7.5, and so that's going to give us 23.55 inches cubed. And this says to go ahead and round to the nearest tenth, so we're going to look in the hundredths place, that 5, so 23.6 inches cubed. Alright, one more application here. So it says baseballs are packaged in a rectangular box. Okay, so we've got a box, and that box is just big enough to hold those 4 balls. The diameter of each baseball is 3 inches. And then we got a couple of questions here. So what is the volume of the box, and how much air surrounds the baseballs? So let's kind of take this piece by piece. We've got this box, and so we can kind of think of it like a cube here, and that's going to hold 4 baseballs. So let's actually kind of look at like a bird's eye view. So if we think about this, and we've got this box, and it's holding 4 baseballs. So we've got 4 baseballs that are in this box. All right, and each baseball has a diameter of 3.5 inches. So that means this one here is 3.5 and 3.5. We've also got another diameter of 3.5 and 3.5. So if we think about that, then the width of this box is going to be 3.5 plus 3.5. Alright, so that's going to give us 7 inches total. And then our length here is also going to be 7 inches. But then the side here, so how tall is this box? Well, the diameter is 3.5, which means that its height actually would also just be 3.5. If these balls are laying flat, right? So you can kind of think of it, if we think 3D here, pretend that I can draw this nicely. So then we've got these balls sitting in this box, and so that depth then would be the same as just one diameter, right? So that would be 3.5. So let's find the volume of this box first. So that volume is going to be length times width times height, and we said that this is 7 inches by 7 inches with a height of 3.5. So my volume is going to be 7 inches times 7 inches times 3.5 inches. Move this over a little bit. We said our height was 3.5 inches. So this is going to be 7 inches times 7 inches times 3.5 inches. Alright, so inch times inch times inch, that's inches cubed. And so then we've got 7 times 7 times 3.5. So that's going to be 171.5 inches cubed. So that's the volume of this box. And so that's our first answer, right? Volume of the box is going to be 171.5 inches cubed. But it also says how much air surrounds the baseball. So this is kind of like the shaded area problem with we got a square with a circle inscribed in it and we subtract. So instead what we need to do is we need to find the volume of each baseball. Okay, and then we can add that volume, so multiply by 4 to get the total volumes of the baseball, and subtract that from the volume of the cube. So remember that volume here for a sphere is 4/3 pi r cubed. I've got a diameter of 3.5. Diameter equals 2r, so 3.5 equals 2r. So I'm just solving for my radius here. So my radius then is 1.75 inches. So let's find the volume of a baseball. So the volume of the baseball is going to be 4/3 times pi times 1.75 inches cubed. So we'll go ahead and use 3.14 for our pi estimate, and then 1.75 cubed, that's going to give me 5.3593 inches cubed. So we've got inches cubed. All right, so let's multiply these out. So we've got that times 3.14. So that gives me 22.4379 inches cubed. So now that means that I've got the volume of one ball, and I've got the volume of the box, but I'm going to need to actually subtract the volume of 4 balls, because we've got 4 balls sitting in that box, right? And so if I go ahead and then I'll take my 22.4379, and that's each ball, right? It has that volume. So if we multiply that by 4, that's going to give us the total volume of the balls. And so that gives me 89.75166 inches cubed. All right, so now we have the volume of the box and the volume of the balls. And so the last step here is we're just going to subtract the two. And so I can take the volume of, so here, how much air surrounds the baseballs? Where I'm going to take the total volume of the box, which was 171.5 inches cubed, and I'm going to subtract the total volume of the 4 balls. Alright, and when I do that, I get 81.748 inches cubed. Alright, so if we think about this, we kind of did this step by step. We took the volume of the box first, so we found our volume of the total box. Then we took the volume, we found the volume of just one baseball. But we knew there were 4 baseballs in the box. Alright, so we started with the volume of the box. Then we found the volume of one baseball. We figured out, oh, there's 4 volumes, right? 4 baseballs, so 4 sets of those volumes. And so we got the total of all of them. And so then the last thing we did is we actually subtracted the total volume of the box minus the volume of the baseballs, and that gave us the space around. So as you see here, the kind of applications that we can do for these volume problems, they vary, right? But this is actually kind of something interesting. It's good to know. If you've got 4 baseballs you want to put on display, but you need to know how big of a box you need, well, this would give you those dimensions so you could actually get the correct size.